Okay, guys, hey, I just have some extra problems on logarithms, so you've got a review that covers all the topics, but if you need help with extra problems, you want extra problems to work, this is an extra set of logarithm problems. It doesn't have the applications like the earthquake, the things we did on the last day, but this covers everything in 1.5, excuse me, 1.1 to 1.4. 1.5 was the application day, so that's not covered in this section, but that's covered in your review, which is 1.6. Convert the following expressions, exponential functions, into logarithm. Go from exponential to logarithm. When I look at this, what is my base? The base is e. So this is the log base e. Exponent is x. In a logarithm equation, that exponent goes on the other side of the equal sign by itself. There's your answer. Now another way of writing this is simply ln of 3 equal x. That's what the natural log means by definition. ln means log base e. If I look at this one, the base is 3. Log base 3. My exponent is m. So the log base 3 of a is equal to m. The next one is log base 10. So you can write it as just log base 10, or if the base is not written, it's assumed to be 10. Exponent is x. Okay. So the log base 10 of 5 is equal to x. So this is going from exponential form to logarithm form. Next set of questions, go from logarithm form to exponential form. I don't see a base here. That means base 10. So this means log base 10 of a equal 15. In exponential form, this means that 10 to the 15th power equals a. If I look at this one, this is log base e. Log base e of x is equal to 12. My exponent is e, excuse me, my base is e. My exponent is 12, so e to the 12 equals x. Log base m, so m is the base, w is the exponent, m to the w equal 13. That's going from logarithm expression to exponential expression. Next set is without a calculator evaluating logarithms. I think we've done some of these in class, but so if I look at this, I don't know what this is. Let's say that it is x. That means that 34 to the x power equals 1. If that is true, then x has to be 0 because 34 to the 0 is 1. So x is 0 in this case. Log base 9, 1/2 log base 9 of 81. Okay, so the way we can look at that is a couple of things. We could write this as, well, let's just do it this way. Be consistent. I don't know what that is. Let's call it x. Okay, that means that if I multiply everything by 2, I get the log base 9 of 81 equal 2x. That means that 9 to the 2x equal 81. And we know from last semester the way we solved this problem, so 9 to the 2x equal 81 is the same as 9 squared. So this means that 2x has to equal 2, therefore x has to equal 1. And that is my answer, x equal 1 in this case. If I look at this, this is using my quotient rule. That's the log base 3 of 18 over 2, which is the log base 3 of 9. Okay, let's figure out what that is. Log base 3 of 9 equal x. That means that 3 to the x equal 9. Therefore, x equal 2. Minus 2, natural log of e to the negative 7th. So minus 2, I'm going to write this as log base e of e to the minus 7. Now, That simplifies. Log base e of e to the minus 7. That's minus 7. So this is just negative 2 times negative 7. This is 14. Log base 2 of 8 plus log base 2 of 4. Using my product rule, that's the log base 2 of 8 times 4. That's the log base 2 of 32. I don't know what that is. So log base 2 of 32 equal x. Convert that to exponential. That means that 2 to the x equal 32. Therefore, x is equal to 5 because 2 to the 5th is 32. 5 times the log of 10. Okay, so we'll say that 5 log 10 equal x. That means that the log of 10 equal x over 5. Convert that to exponential. Remember, this is log base 10. 10 to the x over 5 equal 10. That means that 10 to the x over 5 equal 10 to the 1. So x over 5 is equal to 1. Therefore, x is equal to 5. Okay. Log of the 4th root of 10. Okay, this is the log of 10 to the 1/4 power. Now, if you remember, this is the log base 10 of 10 to the 1/4. This is 1/4, because you know that the log base b of b to the x is equal to x. Okay. Log base 4 of 1 over 64. So log base 4 of 1 over 64. I don't know what that is. Let's say that it's equal to x. That means that 4 to the x is equal to 1 over 64. Another way of writing that is 4 to the x equal 1 over 4 cubed. That's what 1 over 64 is. That means that 4 to the x equals 4 to the negative 3. Therefore, x equal negative 3. So that goes with this problem right here. Okay. The log base 6 of 36 to the 5th. Log base 6 of 36 to the 5th. Well, that's the same thing as the log base 6. 36 is what, 6 squared? So this is the log base 6 of 6 to the 10th, which is just 10. The log of negative 1, okay? This is undefined, okay? You can only take the log of a positive number, so you must take the log of a positive number, or remember that the domain of the logarithm is 0 to infinity. Log base 9 of 9 to the negative 8. Don't waste much time on this one. Log base 9 of 9 to the negative 8 is negative 8. Log base 5 of the square root of 5. Again, don't waste much time on this. The log base 5 of 5 to the 1/2. That's what square root means. Log base 5 of 5 to the 1/2 is 1/2. Okay? After evaluating logarithms, we did some things where we condensed logarithms. So condense this into one expression. So this is going to be log base 2 of a cubed plus the log of ac squared minus, and these are all log base 2, log base 2 of m to the 1/2. So this is going to be the log base 2 of a cubed times ac squared over m to the 1/2. I would probably take that as a final good answer. You can combine these a's, so also another good answer for this would be log base 2 of a to the 5th c squared over m to the 1/2. Okay. Part B, condensing this into one log expression. This is going to be the log of 2x to the minus 3 plus the log of 3y squared minus the log of z to the 4th. Okay, so this is going to be, if I use the product rule, I'm going to have the log of 2x to the minus 3 3y squared over z to the 4th. And one final simplification, I don't like to leave negative exponents, so I can write this as the log of 3y squared over z to the 4th 2x cubed. The way I handle negative exponents, if I find them in the numerator, they become positive when they go to the denominator. Okay? Let's expand the following logarithm expressions using log properties. Do not leave exponents or radicals in the final answers. So this is going to be the log. So if I use the product rule, quotient rule, this is xy to the 4th minus, and let me back up. This is the natural log. Natural log of xy to the 4th minus the natural log of 3e. So that is the natural log of x plus the natural log of y to the 4th minus the natural log of 3 minus the natural log of e. Okay, so remember, when you've got minus the natural log of 3e, that's the same as minus natural log of 3 plus natural log of e. So minus natural log of 3 minus natural log of e. So this becomes the natural log of x plus 4 natural log of y minus natural log of 3 minus natural log of e. Okay. Now there is one simplification here, natural log of e. So the natural log of e is the log base e of e to the 1. That is simply 1. So this is natural log of x plus 4 natural log of y minus natural log of 3 minus 1. That's as simple as this one can get. Let's look at the part B here. I've got quotients, I've got powers, I've got products. Let's take care of the quotient first. This is the log base 2 of 8 square root of x minus the log base 2 of the cube root of y. Okay. Another way of writing that, this is going to be the log base 2 of 8 plus log base 2 of square root of x minus log base 2 of cube root of y. Get rid of those square roots and cube roots. I'll write those with exponents. So this is the log base 2 of 8 plus the log base 2 of x to the 1/2 minus log base 2 of y to the 1/3. And finally, this is the log base 2 of 8 plus 1/2 log base 2 of x minus 1/3 log base 2 of y. Now there is one further simplification, the log base 2 of 8, if you see that, log base 2 of 8 equal x. That means that 2 to the x is equal to 8, or x is equal to 3. So this right near, this is simply 3. So as simple as it gets would be 3 plus 1/2 log x plus 1/3 log y. These are all log base 2's, and that's not a plus, that is a minus. Minus 1/3 log base 2 of y. So these are a little bit harder than what we've seen in the review, but I'm trying to push you a little bit if you want to get ready for the assessment to make sure your concepts are solid. Now this one, I'm solving a log equation. They come in two flavors, log on one side or log on two sides. This looks like it's going to be a log on one side if I can combine these. So if I can write this as 2 equal log base 7 of 5x over 6. Now I've got the log of something equal an expression. Log on one side. The way I solve this is I convert to exponential form. Okay, that means that 7 squared equal 5x over 6. That means that 49 equal 5x over 6, which means that 5x equals 6 times 49. That is, what, 300 minus 6, 294. Let me double check it. So 6 times 49 is 294, yep. So x is equal to 294 over 5. That's my answer. If I look at this one, I've got logs on one side, so I'm going to rewrite this as the log of x times x minus 21 equal 2. I want to convert this to exponential. The base here is 10. So this means that 10 squared equal x minus 21. That means 100 equal x squared minus 21. Let's set this equal to 0 and solve the quadratic. This means that x squared minus 21 minus 100 is equal to, excuse me, let me back up. This is x squared minus 21x. So x squared minus 21x minus 100 equal 0. So I've got to solve that. I'm going to try to solve with factoring. That means I need two numbers that multiply to 100 and add to give me a negative 21. So two numbers that multiply to negative 100 and add to negative 21, those numbers are 25 and 4. When I multiply those numbers, I get negative 100. When I add them, I get negative 21. So this means that x minus 25, x plus 4 equals 0. So x is equal to 25 or negative 4. Those are my proposed answers, okay? I have to substitute those back in to see if they are valid. So if I plug in a 25 for x, that's the log of 25. This next term, that would be the log of 25. That would be the log of 25 minus 21. That would be the log of 4. Okay, that works. Plug in a negative 4. The minute you plug in a negative 4 here, you get the log of negative 4. That does not work. That's undefined. So your only answer is x equal 25. So when you get these two answers for these equations, you've got to go back and check them to make sure that they're valid. So let's look at the next one. Now, what I see here, I see logs on both sides of the equation. So if the log of x squared minus 2x equal 40 minus 5x, then in some ways it's an easier problem. That just means that x squared minus 2x is equal to 40 minus 5x. That means that x squared, if I add 5x to both sides, so plus 3x minus 40 equals 0. That is a quadratic. I need two numbers that multiply to give me a negative 40 and add to give me a 3. Okay, those numbers would be, I think, an 8 and a 5. If the 5 were negative, those multiply to negative 40, those add to 3. So this is x plus 8, x minus 5 equals 0. That means that x is equal to 5 and negative 8. Now let's go substitute any of those back in. If x were 5, then this becomes 25 minus 10, that's 15. And this becomes 40 minus 5 times 5, that becomes 15. That works. Plug in a negative 8. So if I plug in a negative 8, so this would be 64 plus, in this case, 16. And over here, I would have 40 minus, that would be 40 plus 40. Both of these work. So both of these solutions will give me positive values. And both of those would be solutions 5 and negative 8. If I look at the next one here, logs on both sides, but on the left, I need one log expression. So that's going to be the log of 3 times x plus 4 equal the log of 5x plus 8. Log of something equal log of something. That means these somethings have to equal each other. So 3x plus 4 has to equal 5x plus 8. 3x plus 12 equals 5x plus 8. And then I'm going to get 2x equal 4. Therefore, x is equal to 2. Final solution for that. Okay. These problems were a little bit more involved than some you've seen in the homework. But they test the concepts of logarithms to make sure that you've got it and you can understand it. The things we did here, everything we did in class, converting from exponential to log, converting from log to exponential, evaluating a logarithm expression by converting to exponential, solving log equations, before I do that, condensing log expressions, expanding log expressions, and then finally solving log equations. These come in two flavors, logs on one side or logs on both sides. The only thing that's not in this review, the Richter scale, those things we did in 1.5, and taking the log of both sides with your TI. But anyway, this is a good extra set of problems to push you a little bit for the logarithm section.